about to start my presentation. I would like to welcome all of you. It is a great honor for me to be here. Please let me introduce myself first, and let me introduce my company. My name is Kouji Takao. Both Kouji and Takao are commonly used as first name in Japan. In my case, Kouji is my first name, and Takao is my last name. Please call me Kouji. I'm a research engineer at Network Applied Communication Laboratory, Ltd., the Japanese company that hired Matt and others. As for me, my work includes anything related to system integration. For example, system design, programming, planning, and meeting with the customers. And I work as the leader of a small team. I develop open source software during my spare time. I'm a MacRuby and cRuby committer. In MacRuby, I am in charge of some of the core parts. In cRuby, I am in charge of the readlem module. You can contact me on email, Twitter, or Facebook. As I said previously, my company's name is Network Applied Communication Laboratory, Ltd. My company is also known as NACL. As you probably know, NACL means salt. Salt is necessary for all creatures to live. This is why we named the company NACL. You can check out NACL homepage at www.nella.jp, but almost all contents are in Japanese. NACL is located in Shimane Prefecture in Japan. The company was founded in 2001. So 2011 is the 10th anniversary. By the way, it's also my own 10th anniversary as an employee. I'm very happy. Oh, thank you. 57 people work at my company. Woo, that's a lot of Rubyists. Oh, isn't it? Just joking. Actually, about half of my coworkers work using Ruby, and 6 people are cRuby committers. The company works with system integration, training, and so on. Please let me introduce the NACL way as I see it. This is our president. His name is Hiroshi Inoue. In a speech at my coworker's wedding party, he said to my coworker, "First, I want you to be happy. Next, I want you to make your family happy. Finally, if you have more happiness left, then please share it with our company." So I think the priority of my company is as follows. First, the employees' well-being. Next, the well-being of the employee's family. And finally, the company itself. So this is why I love my company. Yeah. Now, let's continue on to the main topic of today. MacRuby on Rails. In my presentation, I will explain how I modified MacRuby to make it a suitable foundation for running Rails. I would also like to explain some of the technical internals that I discovered along the way. First, I would like to first briefly explain about MacRuby. MacRuby is a unique blend of Ruby 1.9 and Objective-C. The goal of the MacRuby project is to be 100% compatible syntactically and behaviorally with Ruby 1.9. Oh, this is Ruby 1.9. This system diagram shows the main building blocks of Ruby 1.9. The top side shows the blocks facing the user, and the bottom side shows the blocks facing the hardware. At the top, we have the applications made by the Ruby user. Below that, we have Ruby 1.9. These are Ruby's main building blocks. We have Ruby VM, Ruby's virtual machine, which was previously called Yavi. We have the built-in garbage collection, which uses Mac and Zip. Then we have the built-in libraries, which includes the string class and the array class, and so on. And then we have the standard library, which includes readline, OpenSSL, and other useful libraries. Below Ruby, we have the system libraries. And below the library, we have the operating system. Ruby 1.9 operates on a number of different platforms, among others Linux, Windows, Mac OS X, and so on. So this is the structure of Ruby 1.9. So let's try to compare this with the system diagram as it looks for MacRuby. We'll look at each element in turn. The application stays as it is. Naturally, Ruby 1.9 becomes MacRuby. Ruby VM is replaced by LLVM. The built-in garbage collection is replaced by a mechanism provided by Mac OS X. This Mac OS X feature is called AuthZone. AuthZone is a generation and threaded garbage collection mechanism. Part of the built-in library is replaced by a feature called Foundation, which is provided by Mac OS X. Object, array, string, hash, and others are replaced this way. The result is that these classes get not only the functionality provided by Ruby, but also the functionality provided by Foundation. For instance, a Foundation method called transform is added to the Ruby strings class. This method can convert the alphabet version of my name, Kouji, into the corresponding Japanese hiragana characters. The standard libraries are more or less similar to Ruby 1.9. The system libraries are also unchanged. And the OS is, of course, Mac OS X. Actually, MacRuby only runs on Mac OS X. So if we look at the whole, well, then it looks like this. So now I have done with my introductory explain of MacRuby. So let's continue with the main topic, MacRuby on Rails. So I'm going to talk about making Ruby on Rails works on MacRuby. Let's see what we can currently do with MacRuby on Rails. Creating a new Rails project, generating a scaffold, starting up the server and showing the welcome page. So it is currently possible to run a Rails application on MacRuby without modifying Rails. However, it wasn't always like this. Let's travel back in time. 7 months ago, March 2011 in Japan, I thought, does Rails work on MacRuby? I tried to install Rails on MacRuby, and I could install. So I thought, okay, it's installed, but I didn't expect the Rails generators would work. I tried to create a Rails project without much expectation, and I could. Not believe my own eyes, I tried to generate a scaffold, then it failed, and starting up the server failed too. After all, Rails didn't work on MacRuby. So what did I do? My approach was to follow the 5-step process shown here repeatedly. First, I run Rails. As the next step, I see where it fails. For instance, segmentation faults, aborted programs, and so on. The third step is to research the cause of the failure. The fourth step is to code a patch that fixes the problem. And finally, I run Ruby spec to verify my patch. And repeat from the top if necessary. In order to do this, I need to know about cRuby, Objective-C, C++, and LLVM. When you just work with cRuby, then you only need to know about cRuby. But when you want to code patches for MacRuby, then you also need to know about Objective-C, C++, and LLVM. So I think that to code patches for MacRuby is more difficult than to do so for cRuby. Now, I would like to discuss a couple of issues that I fixed in MacRuby, for example. Let's have a look at the first case, which is track issue number 860, an issue with catch and throw and exception handling in MacRuby. This error can be reproduced by this code. If you can run this code, then the following error will occur. This kind of exception handling is used by bundler. So in order to make Rails work, we need to fix this error. Let me try to explain this reason. First, we need to know a little bit about how exception handling is done in MacRuby. Have a look at this code. In this program, we raise and rescue twice. Let's look at what happens when we run this program on MacRuby. On line 2, we raise exception A. On MacRuby, raise exceptions are stored in a stack. We call this stack the exception stack. On line C, we rescue exception A and continue execution. On line 5, inside the rescue block, we raise exception B, so exception B is pushed onto the stack. On line 6, we rescue exception B and continue executing the code. On line 7, we reach the end of the inner rescue block, So MacRuby pops one exception of the stack. And on line 8, we reach the end of the outer rescue block. And again, we pop an exception from the exception stack. So now we are done handling all the exceptions raised by this program. And the exception stack is empty. This is the way that MacRuby starts and processes exceptions. So let's look at how exception handling is carried out when in combination with catch and throw. Have a look at this code. In this program, we define a catch block labeled foo. Inside the catch block, we have a begin rescue where we raise an exception. And in the rescue block, we use throw to jump out of the begin rescue. Let's step through the execution again to see what happened in the MacRuby exception stack, just like we did in the last example. On line 1, we define a labeled block using catch. After that, if we call throw with symbol foo as an argument, then we jump out of the block. On line 3, we raise exception A, so it is pushed onto the stack. On line 5, we call throw with symbol foo as the argument, so we jump out of the labeled block. The MacRuby pops exception A from the stack. So this is how throw takes out exceptions from the stack in MacRuby. Before I patch it, MacRuby's throw was implemented as you can see here. This code is from bm.cpp. Throw is implemented in C++. The current exception function returns the topmost exception from the stack. And the pop current exception function pops one exception off the stack. Now, have a look at the code that reproduces the error once again. On line 2, we raise exception A, so exception A is pushed onto the stack. On line 4, we call catch and throw. Then MacRuby pops one exception of the stack, and the stack is empty. On line 5, we reach the end of the outer rescue block, and again, we pop an exception off the stack. However, the stack is empty. Therefore, MacRuby aborts. As you can probably see, that the cause of the error has popped one exception of the stack on line 4. Let me explain how to fix the error. First, let's look at what happens when we run this program on MacRuby after we fix the error. Up until line 3, things work as they always did. However, now things work a bit different from line 4. Now, when we call catch, then we start a record of what is at the top of the exception stack. In this case, exception A. Next, when we call throw, we compare the exception that we start with the exception at the top of the exception stack. If these two exceptions are the same, then MacRuby doesn't do anything. If they are different, then MacRuby pops one exception off the stack. Now in this case, they are the same, so MacRuby doesn't do anything. On line 5, MacRuby pops an exception from the stack. And then the stack is empty. So this is how the new implementation of throw works. So I changed the implementation so that MacRuby only pops exceptions when needed. So the code in the green frame is where we compare the stored exception with the exception at the top of the stack. And in this part, MacRuby pops one exception of the stack. So in short, we keep popping exceptions of the stack until the while condition turns false, or in other words, until we reach the recorded exception. Finally, let's look at what happens when we run a more complex program on MacRuby with the fixed implementation of throw. On line 2, we raise exception A, so exception A is pushed onto the stack. Line 4, we call catch and store exception A. Line 6, we raise exception B and push it onto the stack. Line 8, we call throw, then we compare the recorded exception A with exception B of the stack. These are different, so MacRuby pops exception B of the stack. Then we compare the recorded exception A with the new top of the stack, which is now exception A. These are same, so MacRuby doesn't do anything. Then we jump out of the labeled catch block. On line 11, MacRuby pops one exception of the stack, and the program finishes without aborting. So this is how I modified the program. Next, let's look at another example of how I fixed MacRuby. This time, we look at track issue number 1192, which is related constant lookup in MacRuby. The issue was the MacRuby failed to correctly look up constants in a number of situations when you use module error and class error. This error can be reproduced by this code. If you run this code, then the following error will occur. Please look at the line with object.class error. In cRuby, when we look for the constant b, we start looking within the green box. So we are able to find constant b. However, in the MacRuby, at that time, we only looked within class error's receiver object. And since constant b isn't defined there, the constant lookup would fail in MacRuby. Constant lookup within a class error or a module error argument is widely used by active support. So, in order to make Rails work, we need to fix this error. To really understand this issue, you must have a detailed understanding of how constant lookup works in Ruby. And this is one of the parts of Ruby's language specification that quite hard to understand. And in most cases, you can get along quite fine without knowing the details of constant lookup in Ruby. Let's have a look at this code. We'll look at it from the top and down. Line 1, we begin the define of module A. And line 2, we begin the definition of module B. Line 3, we define a constant called const in module B. Line 4, we reopen the top level module A. In other words, the module A that we define in line 1. And finally, on line 5, we print the constant content of the constant const to the standard output. In this example, cRuby would look for the constant const within the green frame. We call the scope represented by the green frame for lexical scope, and cRuby would find the constant const that is defined in module B. So you see the constant lookup resolution is done in lexical scopes. We call it lexical constant lookup hereafter. At the time, MacRuby had not implemented lexical constant lookup. In this code, on line 5, MacRuby only looks for the constant const within module A. Therefore, const cannot be found. Next, we have example with class eval and cRuby. Const lookup becomes even more complex when we use class eval. The behavior changes depending on whether we pass a block or a string as an argument to class eval. In the code example on the left hand, we pass a block. And in the right hand example, we pass a string. Except for the different arguments, the two examples are identical. First, I'll explain about calling class eval with a block. Let me explain this code sequentially from the top. Line 1, we define module A. Line 2, we define the const. Line 3, we define method f. Line 4, we pass a block to class eval. Line 5, we print the constant content of const to the standard output. Line 6, we close the class eval block, so when we call method f, then line 4 to 6 will get executed. Line 10, we define class k. Line 11, we define another constant called const, but this time inside class k. As you can see, on line 12, we extended class K with module A. On line 13, we call module A's F method. As a result, the code in line 4 to 6 is called. So, can you tell from what scope the constant lookup starts in this case? In this case, it is easy to tell. We look for the constant const within the green frame. So in this case, the P output the string is const. Next, let's look at performing class eval with the string argument. The code example only differs on line 4 to 6. On line 4, we pass a string to class eval in the form of a here document. On line 5, we print the content of const. On line 6, we close the here document. Just as before, we call module A's F method on line 13. So, can you tell from what scope the constant lookup starts in this case? Actually, we would look for const within this green frame. Let me explain the reason. Whenever we call module A's F method, we parse and evaluate the string that is passed to class eval, and the scope in which we look for const is determined to be the scope in which the method f is run. Therefore, the lookup scope becomes the content of class K. As you may know, we call this kind of scope for dynamic scope. So in this case, the P outputs the string case constant. So let's look at the two cases together. We can see that The scope of the constant lookup differs greatly depending on the kind of argument passed to class eval. It was not easy to fix this error. I had to start over twice, and I was finally able to find the satisfactory solution in the third attempt. I edited more than 3,000 lines of code. When I finally managed to fix this error, Laurent, who is the main developer of MacRuby, wrote the following to me. It's officially, Kouji is the hero of the day, week, month. His patches seem to fix remaining lexical const lookup bugs. And that made me very happy. Yeah. However, after enjoying a brief victory, I soon found a new and difficult issue related to constant lookup. This error can be reproduced by this code. Let me explain this code section from the top. Line 1, we define module A. Line 2, we define const B under module A. Line 5, we specify module A as receiver and call class eval with the do block n. Line 6, we are inside the class eval block, so the current receiver is module A. Therefore, this means that we defined the class method f of module A. Line 7, we output the constant b to the standard output. And on line 11, we call method f of module A. This means that we are going to have a lookup constant b. We are now using a patched MacRuby which implements a lexical scope. This means that we are going to start looking for constant b within the green frame. Naturally, we failed to find b within the green frame, so we want to continue our search for b. This time, we look in object for constant b. This also means that we are going to look for a constant called b that is defined at top level. Here, I would like to add a word of caution. Class eval does not add its own receiver to the constant lookup scope, and this behavior is part of Ruby's specification, so I expected that the search for constant b would fail. Surprisingly, cRuby 1.9 found constant b in module A, so it succeeded to find the constant b, even though it should fail according to the Ruby specification. On the other hand, Ruby 1.8.7 worked as expected and failed to find the constant b. MacRuby failed as well. So I asked Matt for advice about this issue. He said this is a bug in cRuby 1.9. And soon thereafter, cRuby 1.9's behavior was fixed to match the behavior of Ruby 1.8.7. Okay, it's time to show you the result of my work. Making Rails works on MacRuby. I will demonstration Ruby on Rails running on MacRuby. I am using Rails 3.0.7, which is a bit old. First, we are going to check MacRuby and Rails version. Okay, MacRuby is 0.11, Rails is 3.0.7. Next, we are going to create a we are going to create a new Rails project. Please wait a bit. Okay. This is also okay. Next, we are going to generate a scaffold. Please wait more. Hurry up. Maybe my machine is old. It's a secret. This is related another bug. Okay. This is also okay. Next, we are going to start up the server. Please wait. Okay. Oh, this is also okay. Finally, we are going to show the welcome page. Oh, this is also okay. This is cool, isn't it? Then let's try to show the Rails info. Hurry up. Oh my God, what happened? Assertion failed. Whom this is aborted. Actually, the server will abort if you click this link on the welcome page. There is still work to be done, and making Rails work on MacRuby is more difficult than I expected. Perhaps even more difficult than implementing lexical constant lookup. So the MacRuby train trip continues. Everyone, please get on board. This is a URL for the MacRuby project homepage. This is MacRuby's official Twitter account. MacRuby is on GitHub. This is the MacRuby mailing list address. So I would like to conclude this presentation with a quick summary of what I had said so far. MacRuby is a unique blend of Ruby 1.9 and Objective-C. The goal is to be 100% compatible with Ruby 1.9. MacRuby on Rails, we are now able to show the default Rails welcome page, but there is still a lot to do. Least of all, I would like to express my gratitude towards the RubyConf hosts and organizers for giving me the opportunity to give this presentation. And I would like to thank my coworker, Toa Yamamoto Sorensen, who helped me with this presentation. And finally, I would like to thank everyone here for patiently listening to this presentation, despite my limited English. Thank you. Thank you very much.